as well, but not right now. I'll share that. Okay, why I didn't see any? Am I recording? Let me check. Yeah, I'm recording already. Okay, good. All right, first, sorry, I forgot the time. So I was very relaxed in my office until I realized it's about 2:10 already. Okay, I'm going to, I like to spend time first for homework 4, and then we go over to homework 5. Sorry, yeah, homework 4 and then homework 5. I want to first pull out the requirement for homework 4. Is this homework 4? Yes, this is. Let me try to make it. Okay, homework 4 is due this Saturday. It's about part 2. Okay. This Friday, sorry, this Friday. It's due this Friday. And homework 5, which will extend it to be due after Thanksgiving. Okay, either you can let my homework 5 ruin your Thanksgiving, or you can relax, have a nice turkey with your family and friends. And then after that, you can work on homework 5. It's okay. By the way, homework 4, homework 5 shouldn't be too hard. And I actually just post some video. I posted a few. In fact, you can imagine I'm actually helping the student before, and I recorded. I have about 3 or 4 lectures dedicated to your homework 5, which back then I was called homework 4 part 3. So it has a lot of explanation, and I try to respond to the question you probably have right now about homework 5. So that's the addition, valuable information for you to see if that will fit your case. But I'm going to answer any question you have with homework 5 after I'm done with this. So I want to very quickly, I also post a video on homework 4 as well, but I realized you can see the amount of video I have. If you actually, I know you didn't, but if you actually view through every single YouTube video I upload for ecs36b, you will realize how much video I actually spent on homework 3, how much I spent on homework 5, but nothing, almost nothing for homework 4. I just realized that homework 4, because it's pretty straightforward. So what you really want to do is just print out a few pointers. So essentially, you want to, for each of the case, you essentially print a few pointer like for A1, E1, S1, W1. There are 4 different pointers, but with multiple inheritance, you're going to have 2 A1 because you have 2 copy of the what do you call that? The 2 copy of the what's A1 stands for? Hold on. Let me get my PowerPoint slide. I forgot what I used the term already. That's sad. It's yeah, account. Sorry, account. A1 stands for account. Thank you. Thank you very much. So there are 2 accounts. One for multiple inheritance, there are 2 A1. But for both multiple inheritance and virtual inheritance, you should have 1 copy of E1, S1, and W1. And let me actually tell you what is the result should look like. If your result looks like this, then you're definitely doing the right thing. Let me bring up the slide. Not this one. We're done with this one this morning. Not this one as well. Is this one? No, not this. Oh, here. So if you look at the Okay, I'm going to use this slide to represent. So this is for multiple inheritance. So multiple inheritance, you can think about there is a one copy of A1, which is going to be on the top. And then let me actually just point to you. The one copy of the A1 should be here, and one copy of A1 should be here. So those two must be different. When I first said we want to print this 4 or 5 variable, the address of this 4 or 5 variable, it should be, let me actually write it down, make it easier. Where's text here? So there is a one copy of A1. Then you will see that the E1 address is a little bit bigger. And then you have another A1. And then you have S1. And finally, you have W1. Okay, so you will get 5 different addresses for this 5 variable for the first part. Okay, the second part, I'm actually asking you to print what? The address of the object itself. So you can take a look at this. I'm actually printing the object pointer. The object pointer was casting. So you will feel a little bit puzzled. Why I'm giving you a pointer and I provide casting, and should they be all the same? Because if you're a C programmer, you know you have a pointer, you have an address, no matter how you cast, it should stay the same. But that's not true in C++. In C++, they're going to change. Whenever you pass those variables, so you in fact have a 4 pointer. One is the original object WS pointer without casting. And then you have cast with employee, student, and account. They're going to be different. So let me actually tell you how the difference will be you're expecting graphically so you can check your answer. Let me get it. Yeah, I have this slide here. Okay, so this is the pointer with casting. You should actually see some of them will be the same, some of them will be different. So let's look at the multiple inheritance. Multiple inheritance. Multiple inheritance is actually easier because if you have the original work study pointer, it must be on the top. So original one must be on the top. And then you have the employee pointer is also on the top. So the original WS pointer and the employee pointer, they should be pointing at the same address for multiple inheritance. And then for the student pointer, it's going to be pointing here. And for if you have, that's essentially those 4 points. 1, 2, which one am I missing? Account. Okay, account is a little bit. Account actually have 2 as well, because of account. The first account was associated with employee is going to be the same as employee, but the account associated with student will be the same as student. Okay, let me actually just write it down here. So I'm talking about multiple inheritance easier, but virtual inheritance is a big company. So what I'm saying here, if you do account star, okay, I'm going to write it in a different line because this is actually a bit long. Let me write down, where should I write? Okay, I'm going to write here. So it's going to be account star, but this is going to be casting employee star, and then WSPTR. Okay, for the account, this is the way to even make it to that pointer. Because first, you have that WSPTR. I don't know which pass you're going to go. Are you going for the employee pass or going for the student pass? So first thing, if I want it to be employee pass, I have to casting with an employee first. After I cast with employee, then I actually am casting with account. Then they will go also pointing to the beginning of the account. So work study, account for employee, and employee itself. Those three pointers should be pointing at the same place. And student, of course, is here. If you change that employee in the black letter, change that employee to student, then they will pointing here as well. So you have two groups for multiple inheritance. And so there are two purposes. Of course, first purpose, want you to be able to write a program to actually realize where is the object. But the other thing, I really want you to make sure you understand how the memory layout was being arranged in C++ multiple inheritance. Okay. All right. So this is actually what you're going to expect with virtual inheritance. You can see that virtual inheritance, I have only 4 because I only have 1 account pointer. And the result you're expecting should be looks like this. By the way, in the program, I give it to you, virtual inheritance.h. Each of the block represent 8 bytes. Exactly. Each of them represent 8 bytes. So when I write things looks like this, I said work study PTR and employee WSPTR should actually pointing to the beginning. The beginning. And after 16 bytes, you skip 2 8 bytes, then you actually get the address of WSPTR. And then you skip another 24 bytes, you're going to get the account. So this is a really, really interesting in a complicated way is that have you noticed that this is the memory address? It's actually exactly opposite because with the virtual inheritance, the account, which is the ancestor or everybody, is actually being put on the bottom. And the multiple inheritance account always goes to the top. So it's basically from the ancestor to the parent to the child. But over here is actually opposite. Okay, that's number one. You should, at least when you get the result, you actually be able to see the result is following this 2 pictures. Okay. The second thing is even more interesting. The first part, your homework 4, you're printing the whatever, W1, A1, the pointer. And for example, E1, remember E1, you print out E1. And the E1 pointer, if you print out for virtual inheritance, it should just between this 2 pointers. So essentially when you print work study, WS pointer, employee is actually here. If you print E1, E1 is actually here. That's the employee because the first 8 byte is actually a virtual table pointer. That's it. They need to handle the virtual, they need that information for the runtime. Exactly the same reason why they need extra pointer for the virtual function because it's a dynamic finding at runtime. So therefore, you actually will realize that if you take your E1 address from the first part, those 4 or 5 pointer, if you minus A, you should get 1 of them. Plus A, you should get another 1. So take a look at the result, whether that makes sense. That's how the correct result should look like. Okay. Question? So there are 2 parts. Just make sure you get the right result. The second part, of course, programming, it will be looks like this. The programming typically looks like this. You just basically take that, you're casting, you kind of assign the address to here and there, something like that. So those are, I basically list all possibilities that we'll need to use to use a pointer essentially is everything instead. Okay. The pointer syntax here. Any questions for homework 4? Yeah.
So you said the rough estimate, how many pointers were printing out for each file?
For multiple inheritance, you should have 5 for the first part. So there are 2 parts. Let me remind myself a little bit. So there are first group of pointer is the address of each of the member variable, which is A1, E1, W1, and S1. So for multiple inheritance, there are 5 of them. For virtual inheritance, there are 4 of them. This group is basically A1, E1, S1, W1, 4 versus 5. But for the object pointer, that how it got affected because of the casting, they both have, let me see, the same thing. Multiple inheritance, you have 5. Virtual inheritance, you have 4. So multiple inheritance have 10. Virtual inheritance have 8 total. Yeah. Yes.
Is it okay if we print out 5 on both so show that 2 are the same? Or do you want to see this print out 4?
You can decide either way. It's fine. I have to ask TA to check whatever you print out. But you should clearly make sure that this part is for which one of those, and this part is for multiple inheritance and virtual inheritance. I want to separate two different outputs, 2 different programs. So you have to write 2 programs. One is called test MI. One is called test VI. Yeah, multiple inheritance and virtual inheritance respectively. Oh, I just realized I didn't use this one. I hope the recording is okay because I'm pretty loud. Sorry about that. Any other questions on homework 4 before I go? Yes, please. Sorry, can you speak a little bit louder? Well, there are 4 for multiple inheritance. The other one is OS copy without casting. So there's 1 for without casting, and the other 3 are those with casting. Okay, any other question? All right, so again, I hope that if you try to do that, Wednesday afternoon, I think this week, let's try to clear both homework 4 and homework 5 out of the door as much as possible. So even though I said homework 5 is due next week, I really don't want to ruin your Thanksgiving. So why don't you just bring your homework 4 and homework 5 question Wednesday after class for 3 hours and Thursday 2 to 5. So those 2 6-hour office hour, let's try to clear this up as much as we can. Yeah, you have a question back there? Yeah. Next week. It's actually due right next Thanksgiving is probably going to be December 1st or December 2nd. Something like that. Yeah. But I mean, you don't need that much time. Okay, don't wait until Thanksgiving after you have to start working on homework 5. That's what I'm saying. All right. So you better get it taken care of because we still have 6 and 7. I'm going to release. You're going to work on that as a team. Okay. And some of you already sent me your final project team. If you haven't done that today, please after that talk to each other. And also, I know there's a lot of people who didn't come here, but Discord, and you should really grab them, okay, to join your exciting team. All right, I'm going to done with homework 4. I'm going to move on to homework 5. All right. Okay, I have a question. How many of you have already started working on homework 5? Okay, good. All right, we have a couple of students already started. Let me see. Where's the tar file? I sent it with the yeah. Okay, let me actually bring the tar file. Oh, I'm going to kill the Zoom, kill the recording, right? Let me disconnect. Am I still recording? Yeah, I'm still recording. I turned off the VPN. Okay, that should hopefully not breaking it. Because I just talked to engineering folks. They said there are some, they will fix the VPN situation very soon. So I asked how soon? Sometime at the end of next year. All right, so okay, so this is the one I'm going to download. I'm going to do it just like you guys are doing it, okay? So essentially, this program is trying to do is you try to implement the dump-J that hasn't been finished. So essentially, especially looking at the reaction object and the comment object, those two parts. That's a part you only need to worry about. And don't worry about web report. I'm sorry, I keep adding this. I forgot to remove it. If you see web report, just safely ignore what I say, because the VPN is just too much and asks you to do any kind of web report. Okay, so all right, I'm going to bring my window here. All right, make. Can you take care of this? Download 5, is that right? What's this? What's the file name? f2021. 5, bingo. So you can see that the directory is still says ecs36b homework 4 part 3, but it's actually in this quarter it's going to be, I call the homework 5, okay? So do I have a make file? Yes, I have a make file. I just make it. Okay, so I have a make file and it has a program called HW4 part 3 dump-J. So I'm going to look at this file first to actually give you an overview about what's going to happen. Okay, this is the program that you can see that this part, the first part, I'm just creating a post. In fact, I'm sorry, I'm not even creating the post. I'm just creating the comments, not the whole post, just the comment and reaction. So you see that I actually create comments, and this part, I'm just creating the comments. After I finish creating a comment, I actually call a dump-J. I just call this function. So what dump-J is doing is look into a C++ objects. By the way, those objects might contain other objects. And then within that object, I actually try to generate a JSON representation of that object. In this case, it's comment. I have a comment, it's a C++ comment. That comment has, as you can see, has an author, which is a person object. It has a message, and it has a JD time. It's representing the timestamp. And then they all put into the comment, and I just do a dump-J. So this line I mark here, it actually create a JSON object. Literally, it's a JSON object, JSON CPP library. And JSON object is generated by the program you're going to develop for dump-J. And then to print out the result, some of you already learned this from homework 3, is that I just take this pointer, I just create it. If it's not null, I check. This morning I say you have to make sure that your pointer is not null. If it's null, if you don't have this check, you might got a segmentation violation right there. So we always check before we actually dereference that pointer. So in that pointer, we call toStyleString. toStyleString is from the program is actually generate a nice nice printout output for the JSON object. Okay, so that's the first one. And the second one is I start to add reaction. So far I only have author, message, timestamp. I didn't have reaction. So I'm going to add some reaction here. I have a reaction. The number one reaction is by Trinity. The second reaction is by Neil. So I have a 2 reaction adding here. And the reaction doesn't have a message. It's just saying whether this is love or this is happy. And after I insert those reactions to the same comment you had earlier. So now it's a single comment with 2 reactions. And now you can do the dump J again. And when you do dump J again, you should actually get a different, it's still the same, right? I'm actually getting this comment to dump J, but I save it in MYV2 pointer. And then I do a 2 style string, and I should get a different result. So essentially what I want you to do is to implement all the dump J function in the code. I'm going to show you which one you need to implement, which one you already have. And then you will be generating the result. And I will provide you a kind of a script that you can compare your output, whether that output is the same as the output for your program. Okay, any question before we go into each of the individual files? Any question? Okay, so let's actually first look at step by step. Let's look at comment, because comment is the immediate one we need to worry about. So under comment, all of them has been implemented except this dump J. You see that the comment doesn't have anything, just the constructor. And then you have a dump J, which is this one you need to be implemented. So this one you need to finish about how do you actually generate the JSON representation of a comment. Let me just show you very quickly about the comment.h. So this is a declaration of comment.h. You can see that I have a bunch of variables like the 3 ID. Remember, the comment has a 3-part ID, profile ID, post ID, and comment ID. They were separated by 2 underlines to hook together. And you have a person, which is the author, and then the message and the JV time. And then you have reactions. This part I explained it once, but I just want to reemphasize again, because a comment you could have multiple reactions. That's why I use a vector of reactions that actually contain all of that. And then you only have 2 functions. One is constructor, one is the dump J. Okay, which is itself is a virtual function. I have to say that for this homework or next homework, that the virtual perspective of this dump J is not that important. I mean, you probably know virtual is very important for shadow object, but virtual in this case is not as important, okay, because we didn't do any kind of different behavior over there. But I do mark it out is for the next homework, which is going to be your homework 6, I'm going to introduce another function called JSON. That's the other direction. Means that you have a JSON object. You want to convert it back to a C++ object. You can see that if you can do both, then essentially you connect 2 words seamlessly. I mean, by the way, that is so important. I just want to tell you that how do I say that? In object-oriented language, to learn each of the linguistic about the language, to me, is not my first priority goal for you to learn. Because let me tell you why. If you speak the same language over and over again, you're going to be really proficient in speaking C++. If you've done homework 3, I give you 10 different kinds of homework 3. If you've done it in 2 months, you will be really expert in any perspective of C++ linguistics. Unfortunately, we only have time to do 1 of them. So I'm not worried about that. let me tell you that this is a very important concept of object-oriented programming, because object-oriented programming is actually trying to model the real world. And in the real world, people are going to use different language to represent their world. Some of us use C++, some of us use Java, some of us use Python, some of us use Ruby. And the thing is that how do we make sure that this world described by different programming language, how would they be able to connect with each other? How can I actually be able to talk to a system represent the object I'm interested, but it's actually being implemented in a different language? And therefore, it's very important to have the capability to know that I want to do interoperability. To do interoperability, you have to convert to some, what I say, standardized platform or representation, and you can actually go back and forth. You can actually, for example, somebody write the JDOM and DUMJ for Python. So he is going to do DUMJ to Python, and you're going to do JDOM to C++. Then your C++ and Python will be able to connect with each other. That's kind of a thing is more important than what you learn about, because I have no doubt you will learn every single language feature that your job requires you to do. I mean, you have to learn and you will get it done. But the thing is that a lot of time people lack of a sense about how to actually be able to do a interoperable. The thinking about how to provide interoperability in object-oriented programming is very critical, very crucial. Okay, having said that, that's common. All right, so now let's look at the second one. Let's look at people, person. I forgot whether I provide person.cpp's DUMJ. Let me look at person.h first. So person.h, you see I have a DUMJ for DUMJ for GPSDD. I have a DUMJ for IP address. I have a DUMJ for person.cpp. This is essentially from your homework assignment number 3. I just add a DUMJ. Remember all the constructor, there are just 4 constructor like most of you eventually deliver for homework assignment number 3. So let's look at person.cpp. Okay, I already provide all the implementation. For GPSDD, I already have one. It's already done. So essentially, I think I only ask you to do reaction.cpp, the DUMJ in reaction.cpp, and DUMJ in comment.cpp. So those 2 are the most complicated ones. The rest is pretty simple. For example, this one, I'm just adding a JSON representation about a GPS object. So what I did is just taking latitude, longitude, 2 key value pair, latitude a double, longitude a double, and then I just provide that, and then that's it. That's the DUMJ, and then I just return. So I give you this code, number 1, to show you example, and also to tell you how you can use this example to extend it to handle the more complicated one. So let's actually look at the next one. This one I think I also done is IP address. I actually make I use a little bit different code. I use a function called inet n2a. So essentially, your IP address is 32-bit number. That's IP version 4. So this 32-bit number, you can use this routine called inet n2a. Is actually converted the number version of the IP address to an IP address like 169.237.6.102 or 127.0.0.1. Those are what we call the ASCII representation of the IP address. So there's a routine you can use myInt. You can see here, this one is just a unsigned integer. This one should be unsigned integer. It was defined by struct in address, and then it generates a traditional C string. Is a character start, which is a pointer to that string with a 0 ended to cut it off. Okay, so that is essentially your DUMJ for IP address. That's being provided as well. Okay, let's look at the person part. The person part, I think I also provided. Oh, I have a message. I even, no, that's a message. Okay, DUMJ is provided. In the person, I just have two things I include. I don't include anything. I just include the avatar name and ESID, those two. And I didn't include other perspective for the person. Right now, we just try to do a simple one, just have two. So you don't need to modify anything, but just use it. You know there is something, because when you try to generate a comment.cpp stumj, you're going to call the person.cpp stumj to print that output. And the result is just return a JSON object pointer, okay? So let's look at the other two, which might be useful is message. Let's actually look at message.h because there is a message part. I think I already implement. Because this one is so short, I thought I just directly implement already in the .h file. So you can see this part is the DUMJ for message. In message, I don't have message.cpp, just to let you know. I just realized somebody asked me this morning. I said, oh, I didn't provide that. And then I realized because message is really so short. The first time I just implement directly in the .h file, just pretty much like how JSON RPC implements some of the stuff in HWT client.h. So you can see that this is the DUMJ for message is the same structure of the code. If you look at this more than 3 times, you will realize the code has a clearly very simple pattern. This is, by the way, the code in your reference implementation. So it's essentially do a key value pair, whatever I want, and then provide the why have a time here? Oh, this is JV time or message? Sorry, let me check. That's strange. Why I have a JV time here? I do have a JV time. I actually put a revision of the time, but let me actually go for the JV time. I thought I implement JV time DUMJ already, so let me check. Very interesting. I actually didn't implement a DUMJ for JV time. I just implemented a string called getTimeString, which might be a bad idea. I just realized I actually put the time associated with the message. Okay, that's something I can improve, but don't worry about for this homework, just using this base, and don't worry about the JV time DUMJ. It should have a JV time DUMJ somewhere. Okay, this is essentially the JV time. You can see that the JV time is just how do I actually handle all the time issue. If you're interested, you can take a look. It's a pretty interesting way for you to basically manage your own time in any way you want. You can handle different kinds of time zone and different kinds of situation. Okay, JV time stands for JSON value time. Okay. All right, so that's pretty much everything. And okay, I want to go one more is reaction.cpp. So reaction.cpp is the same like a comment you have to implement. So essentially you need to implement those two, reaction.cpp and the comment.cpp, okay? I just want to tell you that I show you segment of code already. Some of the previous video, if you go back to check, it will give you even more hint about how you can do the reaction. Probably the only tricky part is how do you actually handle array in the DUMJ? Because previous one, person, message, or GPS, DDI, they're pretty only one layer of JSON object. But with comments and reaction, you're going to have a vector of JSON object circulate in the array, which is also not hard, but it's a little bit different. Okay, any question? All right, so I'm going to post this video. You have one more thing to worry about. Okay, But otherwise, I'm going to see you on Wednesday. So this Wednesday after class, again, 3 hours in the academic search. Yes, please. Anytime this week. If you want to meet with me this Wednesday or Thursday, we can meet half an hour. What? Yes, yes. After class, final part is my highest priority.
Yeah. And I just finished the homework for on the class. Yeah. Hey, Professor, I have a good question.
Let me turn off the recording first.
A1 makes sense.